Hi, my name is Kevin Driver and I'm a senior field engineer with Newbridge Networks, and I work out of the Orlando region. Basically what I'd like today is talk to you about the installation of a 3620 unit, and we're going to talk about the installation, the configuration, and the maintenance of the unit. First thing you're going to need is the basic tools to do the installation. You're going to need a static mat, you're going to need screwdrivers, a Phillips and a slot head. You're going to need basically a pair of dikes to do some cutting with, and you're going to need a static strap, okay, to ground yourself. From there we move to the 3620. This is a 3620 wall-mounted unit. It's going to basically mount on a wall. Then from here we move to the various modules. Top module you have is a V.35 aggregate module. Then you have an OCU3 module that's located below it. Then we step to actually what's going to be mounted inside the 3620. We're going to go to a DTU chip. The next card would be a CSU2. And the last card will be actually the memory module that goes in the 3620. From here, we go to what we call a UDP, or a Universal Distribution Panel. And this is what the Universal Distribution Panel is. It has various module slots that you can plug into here, what we call personality modules. The ones that we'll be specifically talking about today will be the V.35 personality module, and we'll be talking about the RS-232 personality module. The other parts that you're going to need, basically you're going to need some ground wire to connect to a good earth ground, and you're going to need an Amphenol cable that's also provided. And then from there you're going to need also some level 5 RJ45, or what we call 8-module RJ45 cable that's going to connect your T1 interface. It's going to connect your PP IP port, and that's going to connect from your personality RS-232 module to your DSU CSU. Now let's get started installing the 3620. Now we're going to take a look actually at the 3624 and what makes up the 3624 and all its internal components. Basically you'll turn the key to open up the side, and then from here you have two screws that basically hold down the main cover here. One on the upper corner and one on the lower corner. Once the screws are removed, then you can actually open up the 3620 and see the internal components. From here you have a 3620 power supply, which is located on the upper top here. Then from there you have what we call the memory module slot. Next will be the CSU slot. The next slot will be the DSP slot. The other parts that make up here are basically 28-pin IC chips. Okay, you have one which is called the DTU slot, which is located here, and one which is the FDL slot. For our specific installation, we will be using actually the DTU slot. From here we go down to the lower part of the 3620, and we actually go down to what we call the universal card slots. You have modules 1, 2, 3, 4, 5, and 6. It's important to remember that these modules correspond to specific connectors that route out of the 3620 and go to their device. From here we'll take a look at actually what we connect to. Modules 1, 2, and 3 correspond to the J1 Amphenol connector. Modules 4, 5, and 6 correspond to the J2 Amphenol connector. And we'll get into later the specific data breakouts that you're going to be using. From here, we're going to take a look actually the connectors that are located on the side of the 3620. The first connector you have is the T1 interface connector, which is located at this point. The next will be your external modem connector for dial-in access to the 3620. Your next connector will be your terminal port. And for your specific application, you're going to be using a PP/IP protocol that connects to a terminal server. The next connector up is actually an external alarm connector that you could be using depending upon the various applications. The next part up here actually is what we call a seven-digit digital display connector that basically displays the alarms, and it's located at this point. This basically explains the internal components that we'll be connecting today, and now we'll go further in depth into the installation of the 3620. Next, we're going to move on to the installation of the internal modules of the 3620. Two things that are very important at this time is to make sure that the unit is powered down and that you find a good earth ground and a static strap to connect to. By installing these modules, you can refer to the change order that is supplied with the 3620 and all its various parts. The first module that we're going to install will be the memory module. And that's located in the J10 slot, and it's a 96-pin connector. To make it very nice and easy, we've removed the nylon screws and the metal screws from the standoffs at this time. But it's also very important to make sure these are reinstalled after completing the module insertions. Next thing we're going to install is a DTU chip. It's a 28-pin IC chip, and it's going to be located down here in slot U36. It's also very important to remember that the DTU chip is keyed, okay, and the EEPROM is keyed, and that it's installed in the correct way. Slide it in very gently and press it down firmly, making sure not to bend any of the pins. The next module that we're going to install will be the CSU. That's located down in the 40-pin connector, which is located here. The next modules we're going to install are the universal card slot modules. First of all, we want to move the hang guard, and the first module we'll be installing will be the V.35 module, and that will be located in module position 1. Next module will be the OCU3 module, and we'll be installing that in module position 3. It's also very important to make sure that the guard is replaced and screwed down securely, holding the modules in place. Next, we're ready for the installation of the unit actually on a wall. If you'll take a look on the left and the right side of the unit, we have various holes that are located here at the top and the bottom and the sides. And now we're going to get the 3620 ready to hang on the wall. Now the 3620 we basically have mounted on the wall. Okay? From here we're going to do two things. We're going to install the earth ground, and then we're going to connect the power, make sure the unit powers up correctly. From here we want to open the unit, and we want to find a good ground that's located somewhere nearby, and we want to find some ground wire. We're going to connect to the stanchion that's located here that basically describes earth ground. And they're going to connect the other end to a good earth ground that's located in the building somewhere. The next part, we're going to connect up our AC power. We want to find a good source of AC power. We want to use a dedicated type of resource. Okay, that means simply there's nothing else that's connected except this 3620. Okay, if you have any questions, you need to refer to your customer documents or whatever is provided for you. Basically, we want to connect the AC power cord, and then the switch is actually located in front of where we do the three-prong plug. And we're going to power the unit on. And the next part of our installation will be actually connecting the universal distribution panel to the 3620, and then we'll move on from there. Next, we're going to install the UDP, or the universal distribution panel. Basically, the point to remember on the universal distribution panel, it is not hinged. It's a keyhole flange type So watch closely how we take the cover off the UDP. Basically, you have two thumb screws located at the bottom. You want to loosen the thumb screws, and you want to take the top of the cover and slide it down and then up. The thing to remember here is that the standoffs are keyed, okay, and the flange is also keyed, okay. From here, we're going to take our universal distribution panel, and now we're going to wall mount it. On the universal distribution panel, it also has a chassis ground. So we're going to make sure we ground it to the same potential or the same source that we grounded our 3622. The next important is to make sure our personality modules match our universal cards that are located in our 3620. For our application, we'll be using two personality modules. We'll be using a V.35 M34, and that will be located in module position A. It's also very important to make sure you have a static strap, like I didn't have one on just then. Next module will be installing this RS-232 module, and that'll be located in module position C, corresponding to our OCU DP3 module. The thing to be very important here is to make sure that our modules correspond to where our universal card slot modules are. For our application, we're basically using modules 1, 2, and 3. Okay, in this case, a V.35 in module position 1, an OCU card in module position 3. How these modules correspond to the universal distribution panel are this way. A corresponds to module position 1, B corresponds to module position 2, and C corresponds to module position 3. Okay. The last thing we'll do is connect up our 50-pin Amphenol to our J1 connector to our universal distribution connector here. So we take our 50-pin Amphenol and we connect it down. And we take the other end of the male Amphenol to our universal distribution panel. The thing to be very important and very careful here is to make sure that we also have nylon ties that are located here, and they have slots in them. And you can basically take a small tie wrap and tie it around the Amphenol connector to make sure it securely fits in place so it never slides out. And that's also located on the universal distribution panel. Okay. Basically, this concludes our hardware installation of our 3620 and our universal distribution panel. Next thing we're going to discuss is connecting the external connectors or cables to the 3620, okay, or the UDP device. In the first scenario, we're basically going to connect the T1 interface, which is the J4 connector. Okay, we're going to connect a straight through RJ45 jack modular connector to the J4 connector. And then we're going to connect that to the telco interface, whatever's provided for your particular site. The next thing that we're going to connect is actually you have two ports here. You have a J5 port and a J6 port. J5 is normally used for an external type modem connection. For the application that you're going to be using a PPP IP port. there's a specific cable that is provided, okay, that is labeled Cisco AUX port and Newbridge J5 port. Okay, so you make sure that you actually plug the module jack in the appropriate position. And you're going to take the other end and plug it to your Cisco auxiliary port, or in some applications there might be an internal Newbridge router located in this slot right here, and then you would connect it to there. The next port is actually the J6 port, and that's the terminal port. And we'll discuss that later when we get actually the configuration of the box and plugging into there. The next thing that we're going to connect to on the UDP is we're going to take a straight through RJ45 jack, and we're going to take a DB25 that is provided, and the pinouts will be in your customer engineering package. And then you're going to connect it to circuit 1, and then you're going to run this to your external DSU. That concludes our connection of our external cables to our devices. Now we're ready to log into the 3620. We're going to be using serial port J6. We're going to make a straight through connection. And we're going to connect the other end to our laptop. You need to refer to your service manual for the specific pinouts. The default for this port is 9600 baud, 8 bits, no parity, 1 stop bit. Now let's go ahead and log into the 3620 and start configuring. Now we're going to log into the 3620. After we're all connected up, basically we need to run some type of VT100 emulation. From here we're going to choose enter or return. We're going to pull up our entry level. In our case we'll be using number 5. Then we're going to choose our password, which is Main Street. And we're going to choose enter. And this is our main menu screen. At the upper left hand corner we have 3620 Main Street. That's the type of unit we're logged into. To the right of it we have the software generic that the 3620 is running. The next would be the alarms. This tells us how many alarms we have active in the queue, followed by the date and the time. On the bottom of our screen we have our main menus or our soft keys. Number 1 is configuration. Number 2 is house. 3 is maintenance. 4 is status. And 5 is alarms. The first thing we're going to configure is our universal card slots. We're going to choose soft key number 1, which is configuration. We're going to choose soft key number 1, again, which is position. Now we're going to configure all the modules in this slot. We're going to choose escape 3, which is config all. And then we're going to choose 0, which is proceed. Once this is done, now we're going to look at the status of the modules we have just programmed. The first column is configuration. The next column is the install type. And the next column is the status. For our specific application, we have installed 2 modules. M01, or module position 1, which is a V.35 direct connect module. It's installed a V.35 direct connect module. And the status for this module is OK. The next module we'll be looking at is M03, which is module position 3. It's configured as an OCU, installed as an OCU, and the status for this module is OK. The next module that we're going to configure is our T1 module. And specifically we're going to get into actually the framing and the coding for this particular module. From here we choose escape 9, getting us back to our main menu. From here we choose soft key number 1, which is configuration. We choose soft key number 1, which is position. And now we enter T1. This is the identifier for the CSU slot. And we choose return. Now if we look at the top of our menu screen, it tells us we have it configured as a T1, installed as a T1, and our status is OOS, in this case meaning out of service. And if we look further to the right, we have options. In this case, the default options are JB7 and D4. Refer to your customer documentation for the specific options that you need to install. For our application, we are going to be running ESF VHS. To configure this, we choose number 3 soft key, which is options. We choose soft key number 1, which is ESF. And then we choose 0 for proceed. Now we're going to change the coding for our particular T1. We're going to choose soft key number 4, which is 0 suppression. We're going to choose soft key number 2, which is BHZS. And now we'll choose soft key 0 for proceed. Now if we look at the top of our menu again, we have a T1, and to the far right we're looking for options. They are now set for VHS and ESF. Now our T1 interface is all configured. Now we're ready to move to the next step. Now we're going to configure our specific data modules for the 3620. First one we're going to configure is the V.35 module. We're back at our main menu now, and from here we're going to choose config, soft key number 1. We're going to choose circuit, which is soft key number 2. Then here we're going to type in M1-1. This corresponds to module position 1, circuit number 1. We're going to choose enter. We're going to choose soft key number 5, which is function. We're going to select soft key number 2, which is rate adaptation. And we're going to choose soft key number 1, which is method. And we're going to select soft key number 2, which is transparent. Now we'll select 0 for proceed. Now we're going to change the interface speed for this particular circuit. We're going to choose soft key number 5, which is interface speed. And now we're actually going to enter the speed for this particular circuit. And our application will be using 256K. We'll type in 256 and return. And it tells us proceed to confirm the change, and we choose soft key 0 to proceed. So now we need to look at our configuration for our particular circuit. So we're going to look at the configuration as screen. So now we look at configuration as. We're in sync, DCE, full duplex. Rate adaptation is transparent, 64K. Our transport position is B7. And our interface speed is 256K, what we just changed. Our data positions are not applicable, and our signaling is not applicable. Multi-drop is disabled, and clock is set for slave lock. Now we're going to configure the control leads for this particular module. From here we're going to hit Escape 8 to back us up one menu. And now we're going to choose soft key number 3, which is control leads. Now we're basically looking at our inputs, and to the right of there are outputs for these particular control leads. We're going to set all inputs to assumed on. We're going to select soft key number 1, which is inputs. Going to choose soft key number 1, which is DTR. And we're going to choose soft key number 1, which is on. Now we're going to press 0 to proceed. Now if we look at our inputs under DTR, it is set for assumed on. Now we're going to select RTS, which is soft key number 2. And choose soft key number 1, which is on. And we will choose 0, which is proceed. Now we have just changed RTS to assumed on. Now we will choose soft key number 3, which is ALB. We will choose soft key number 1, which is on. And soft key 0, which is proceed. Now ALB is assumed on. Now we'll select RDL, which is soft key number 4. We'll choose soft key number 1, which is on. And we choose soft key 0, which is proceed. Now RDL is assumed on. From here we were going to choose escape 8 to back up one menu. Now we're going to select our outputs, which is soft key number 2. The first is DSR, which is soft key number 1. And as you can see, that is already turned on by default. So we'll hit escape 8 to back up one step. The next one will be soft key number 2, which is DCD. Soft key number 1, which is on, and 0 for proceed. The next one we choose is soft key number 3, which is CTS. Soft key number 1, which is on, and 0 for proceed. The next one is RI, which is soft key number 4. Soft key number 1 is on, and 0 for proceed. Now we can take a look at our inputs and outputs. We can check and make sure everything is forced on or assumed on, depending upon the input or output state. DTR is on, RTS is on, ALB is on, RDL is on. Our outputs are DSR, which is forced on, DCD, which is forced on, RTS, which is on, and RI is on. Now we are going to configure the OC3 module. From here we would choose Escape 9, and now we're located back at the main menu. From here we would choose Config, which is soft key number 1, Circuit, which is soft key number 2. Now we're going to type in M3-1, which corresponds to module position 3, circuit number 1 of our OC3 module. Now we will choose Enter. Now if we look at the top of our screen, we have circuit, which is M3-1. Type is OCU. Interface speed for this particular circuit is 9600. tells us our DSU is absent, fault signaling is seized, and status is out of service. Just a quick note, what this simply means is we have no DSU connected to our circuit at this time. When we have an active DSU, the status will be okay. And the DSU will signify present. From here, we're going to choose soft key number 5, which is function. We're going to choose IF speed, which is number 1. And we're going to choose 56K or 56,000, which is soft key number 5. Now we will choose proceed. Now at our top screen, if we look at our interface speed, it's changed from the default of 9.6 now to 56K. This concludes configuring our V.35 module and our OCU module. Now we're going to make a connection between these modules and the T1 interface. Now we're going to configure our individual DS0s for our specific applications, and we're going to make those cross connections to our individual universal card slot positions. The first thing we're going to do is configure our T1 DS0s. From here we're going to choose config, which is soft key number 1. We're going to choose circuit, which is soft key number 2. And now we're going to enter our circuit position, which is T1-1. The 1 corresponding 1 through 24 for each individual DS0's positions. We would choose enter. Now if we look at the top of our screen, we have circuit configured as T1-1. Type of signaling is T1 sig. Our function is RBS on voice. Our fault signaling is idle. And our status is configured. The most important thing to remember here is if you choose to run 64K over a DS0, you must turn RBS off. So now we're going to configure our first 4 DS0s for RBS off to accommodate our 256K data circuit we programmed earlier. From here we're going to choose function, which is soft key number 5. We're going to choose RBS off, which is soft key number 1. And now we're going to press proceed, soft key number 0. Now if we look at the top of our screen, under function, RBS off is turned off. Now to speed this up, we could actually program each individual circuits, but we have a copy to command, which is soft key number 3. So we will choose number 3, copy to. And now we will enter the specific circuit we want to copy this configuration to. For our instance, we'll be going to T1-2, enter, and 0 to proceed. Now we will choose the copy to command again. We will type in T1-3, which corresponds to the circuit number 3 of this T1. Return, and 0 to proceed. And for this application, our last one, which is we will hit the copy to command number 3. Our last circuit is T1-4. Return, and press 0 to proceed. As you've noticed, up the top our main screen is not changed. Our circuit is still T1-1. So to verify that you've actually configured RBS off for these particular DS0s, we would hit soft key number 1, which is show group. Now if we look at under circuits, under circuit number 1, 2, 3, and 4, under our function menu, we have RBS off on each one of these 4 DS0s. Now we were going to hit Escape 9 and go back to our main menu. Now we are ready to connect our specific V.35 circuit to the DS0s that we just have programmed. We will choose soft key number 1, which is config, soft key number 3, which is connect. Now we will enter the module position we are connecting, which is M1-1. Understanding module position 1, circuit number 1 for this particular card. We will hit enter. Now we pull up soft key number 3, which is to circuit. And now we will enter the first DS0 that we will be connecting our 256K V.35 circuit to, which is T1-1. Hit return and hit 0 to proceed. Now if we look at our top screen, we have circuit M1-1. Type is V.35 DCM. The next key is the circuit that it's actually connected to, which is T1-1. Type is T1 V.35 DCM. We now actually have a circuit connection or a logical connection between our V.35 card and our DS0s going out to the telco. Now we're going to connect up our OC3 module. From here we would choose an escape 8 to back up 1 step. Now we're going to choose module M3-1 corresponding to module position 3, circuit number 1 of the OCU module. We choose enter or return. Select soft key number 3, which is to circuit. And now we enter the circuit. In our application, it will be T1-24. And return. Now we press proceed to make the connection. Now if we look at our top of our screen, we have M3-1, type OCU, connected to circuit T1-24. Type is T1 OCU. If you refer back, we're only running 56K on this particular application. So we do not have to program our DS0 or T1-24 for raw bit signaling off. Now we're going to choose Escape 9, and now we return back to our main menu. The next step is to configure the housekeeping functions of the 3620. Basically, we're going to set the node name, the date and time, the serial port connections for IP to our router, and we're going to set up the IP address. First thing we're going to choose is housekeeping, which is soft key number 2. Then we're going to choose soft key number 5, which is node name. And the naming scheme that's to be used is the name of the airport ID plus NB01. For our demonstration, we'll be at the Memphis location, so it's MEMA NB01. Return, and 0 to proceed. Now if we look at the upper part of our screen, to the right of our software generic configuration, we now have MEMA MB01. Now we're going to select our date and time. Choose soft key number 3, which is date. and it gives us a specific format that we need to enter this in. It gives us day, 3-digit month designator, and the 2-digit year designator. It's the 12th dash November dash 96. Return and proceed. Now we're ready to configure the time, which is soft key number 4. Also gives us the specific format that we're to use, hours and minutes. Enter 1:12 p.m. or a.m. In our case, p.m. Return and 0 to proceed. Now if we look at our upper right hand corner, the date is the 12th of November 1996. To the right of there is the time, 1:12 p.m. The next step that we're going to configure will be our specific serial ports. If we look just below our main header, under ports, we have located ports 1 and port 2. Port 1 is the specific port that we are logged into right now to do our configuration. Set for baud rate of 9600, port type VT100, flow control is none, CPSS cost is not applicable, and link status is not applicable. For serial port 2, this is the port we're going to be mainly connecting to our router. It corresponds to the J5 port. Port number 1 baud rate is 9600, and the port type as we speak is CPSS modem. This is by default. We're going to change this to PPP/IP. To do this, we select soft key number 2, which is serial port 2. We choose port type, which is soft key number 2. And we choose soft key number 2, which is PPP/IP, which is soft key number 2. Hit 0 to proceed. Now if we look at our serial port number 2, under port type, we see that it has changed from default of CPSS modem now to PPP/IP. Since we're connecting this 3620 to an IP network, now we have to enter the specific IP address. From here, we are going to choose Escape 8 to back up one step, one menu. We're going to select the soft key number 7, which is More. And we're going to choose soft key number 6, which is IP address. Now you will enter the specific IP configuration that should be supplied on the configuration data form. Okay? Each address will be specific in your network. For our demonstration purposes, we will enter 192.55.23.1. Now you choose Return and hit 0 to proceed. And this is very important to look at. We look under our house prompt. We basically have a script that says a system restart is required to have this operation take effect. And if we look at our house menu under IP address, it tells this time that the current address is programmed, but actually the address that is active is 0.0.0.0. So we have to turn the 3620 off at this time for this IP address to take effect. This basically completes the configuration of the Newbridge 3620. Next thing we want to take a look at is basically some maintenance and troubleshooting of in the field when you make your connections to your PPP port and your T1 interface. First of all, we'll take a look at the PPP port, which is going to connect to the router. To check the status of this port to make sure that the link status is up or down, we will go to soft key number 2, which is house. And if we look here at our port types, we have serial ports 1 and 2 as we discussed earlier. And port 2 we set for 9600, port type PPP/IP. Flow control is none. CPSS cost is NA. And the most important thing is the link state. And what this is telling us is actually for passing a good protocol signal between two endpoints. In our video, you see that our link state is actually down at this time. If we were connected to a good AUX aux port or an AUX port, and we had a good connection to our serial port 2, which is J5, this link state should be listed up at this time. The next thing we're going to look at is actually the T1 to make sure that we've actually come in sync with the T1 interface that comes into our facility. From here we would go escape 9. The first thing we're going to look at is soft key number 1, which is configuration. And we're going to look at soft key number 4, which is sync. And what we're mainly looking for here is our source number 1, which is number 1 is T1. The recovery is auto. Priority is 1. Threshold is unlimited. And the status is auto recovery. And if we look further down in the screen, it tells us what actually we're running off at this time, or what our current source of synchronization is. Right now, our current source of synchronization is number 6, which is set for free run. What we're going to do now is connect up our T1 interface, and you'll be able to see the change in status that takes place on our screen. If we want to change the status, we would simply hit Escape R to refresh the screen. Now we're going to look at our sync source number 1. Source is T1. Our recovery is still auto. Our priority is 1. Our threshold is unlimited. And our status is current. The current source of synchronization is number 1, source T1. So now we are actually seeing a good clocking signal off the T1 we have just interfaced to. The second spot we can check to make sure our T1 is in sync with our network would be config position. From this menu screen here, we would choose escape 8. We would choose soft key number 1, which is position. And we would type in T1. Return. If you can recall earlier, when we looked at the same screen, when we were configuring the coding and the framing, our status was OOS, which simply means out of service. Now that we have a good T1 signal coming in, our status is OK. So these are the two main things to check: that you have a good link status on your PPP port, and that your T1 is in sync to the telco network. From here we're going to look at the LED displays of the 3620, which are located on the front panel. Our first LED is power. It should be lit solid green at all times. Our next light is event status. The two light indicators here are amber when there are active alarms in the queue. Again, that is when there are active alarms in the queue that have not been deleted or have not been acknowledged. If there were no alarms in the queue, the event status would be off. The next LED is system status. System status basically looks at all the modules as a whole in the bank. If there are any modules that have a fault status, then the system status would be on. I'll demonstrate a T1 out of service and what it looks like to the system status. As you've noticed, the out of sync light goes red and the system status comes on. Now we'll plug back into our T1. Our out of sync light goes off and our system status should clear momentarily. And it's just cleared. The next LED is the processor. Basically, this should flash continually, on and off. It should never be off, and it never should be lit solid. We've just discussed what the out-of-service LED indicator means. Basically, that looks at the T1 interface, and it tells you if you have a good framing signal and good clock coming in. The next indicator is link quality. That simply monitors the link quality of the T1 circuit coming in. It should be off at all times, and if the link quality is marginal, it will be lit solid. That basically describes in depth of the LEDs that you will encounter and the troubleshooting that you can do via the NMTI screen of the 3620. We're ready to wrap up. We basically have done a hardware installation with 3620. We've done a software configuration of the 3620. And now we're ready to basically connect our external cables, talk about the applications that you've just set up, and tidy up our installation. Basically, our UDP, we're going to have two interfaces coming off of here as we discussed earlier. You've got a V.35 M34 connector here, which will connect to your router. And for our application, we actually programmed this for a 256K router circuit or a 256K transparent circuit. And we're going to connect our M34 cable here to our router, and that cable will be supplied in your installation kit or package. The next one will be your RS-232DB25. In our case, we're using an OCU module and a special head shell and cable that's been provided to you. You're going to refer to your engineering package for the specific pinouts for the DB25 RJ45 user configurable head shell. Then you're going to connect this up to circuit number 1, and they're labeled circuit 1 and 2, and you're going to tie this down, and then you're going to run this to the DSU. And this is going to be specifically for your SNA traffic. And if you recall, this was the 56K circuit that we connected to channel 24. From there we move to the 3624, and we want to disconnect our terminal port. And we want to make sure all our modules are in place. We want to make sure that our hinges are locked down and all our screws are installed according to what we talked about earlier. We want to close the cover. We want to screw our external hinge or outside cover back down. And then we want to close our unit. Always keep in mind you want to have your work area nice and neat and clean. You want to dress your cables accordingly with tie wraps and make it look nice and neat. The last thing we're going to do is actually put our cover over our UDP. We're also going to dress our cables here, and we are given places where we can tie our cables down. We want to leave plenty of slack, and that's why the cover is kind of large. So now we're going to take our cover, slide it down over the hinges, and up. And screw it into place. And that completes our installation of a 3620 hardware and software configuration, and good luck.